This episode describes the PF ratios method for synthetic cohorts. In episode 2, we review the standard PF ratios method. In this last episode of Module 4, we will review the PF ratios methods for synthetic cohorts using data from two censuses. If you want more detailed information about the steps to estimate PF ratios for synthetic cohorts, please see Annex 2 in this module. This module provides a basic description of the PF ratios methods for synthetic cohorts and is used in evaluating coverage of birth recordings from census when fertility recently changed. The PF ratios method for synthetic cohorts uses data from two censuses and observes average fertility during the intercensal period instead of assuming constant fertility levels as the standard PF ratios method. To provide an overview of the method, first, I'll provide a list of tabulations needed to apply it. Then, I'll cover its assumptions and logic, as well as a brief description of how to conduct its estimation. I will provide an example of adjustment factors and its interpretation. I'll close this module by discussing the method's advantages and comparing it to the standard PF ratios method. You will need the following tabulations from two censuses for estimating PF ratios for synthetic cohorts. First, children ever born classified by 5-year age group of mother for each census. Second, births in the year preceding each census classified by 5-year age group of mother. And third, women by 5-year age group for each census. Let's remember the three assumptions for the standard PF ratios method using data from a single census. 1. Fertility is not changing over time. 2. Reporting of the number of children ever born alive or average parity is essentially accurate. And 3. The number of births can be distorted, but the age pattern of births is not distorted. The PF ratios method for synthetic cohorts relaxes the first assumption that fertility is constant. The other three assumptions of the method are: 1. The assumption of robustness of reports of the number of children ever born alive for women under age 35 is similar in both methods. In this method, is extended to 2 consecutive censuses. 2. The method assumes that the proportion of births underreported in age-specific fertility rates is the same at all ages. And 3. The last assumption is that mortality and migration have no effect on actual parity distributions. Again, note that the PF ratios method for synthetic cohorts no longer assumes that fertility is constant. The standard PF ratios method previously described assumes that fertility has been constant during the last 15 to 20 years preceding the time of the census. However, if fertility levels have declined, as has been the case in most countries, the application of the standard PF ratios method will result in biased estimates. The application of the PF ratios for synthetic cohorts uses parity and fertility measures for the intercensal period and accounts for the changes in fertility when adjusting fertility levels. Note that there are substantial changes in fertility from 1970 to 2010 for most regions. Africa fertility levels have declined and will continue its decline in future decades. The basic principle is the same in the standard and the synthetic cohort PF ratios method. There should be consistency between information on parity and cumulated current fertility across women's age groups. However, in the synthetic cohort method, changing fertility is addressed by using data from two censuses. The method uses cumulated cohort increment of average parity between two censuses. It uses age-specific fertility rates average across two censuses to calculate parity equivalence for a non-observed intercensal cohort. For this reason, we call the method PF ratios for synthetic cohorts, because we do not observe a group of women with average cumulative age-specific rates or average parities, but model a cohort of women subject to intercensal rates for both fertility measures. Let's discuss the concept of synthetic cohort in more detail. In this case, A synthetic cohort is a fictional group of women subject to unobserved average intercensal fertility conditions. Parity and lifetime fertility equivalents are estimated averages on changes observed between 2 points in time. These average rates are used to simulate the effects of changing fertility conditions within the intercensal period on a fictional group or synthetic cohort of women of reproductive age. Annex 2 provides a detailed explanation of the estimation of intercensal averages. We avoid the assumption of constant fertility and use average data from two censuses to obtain unbiased evaluation and adjustment factors for underreported births. We do this by computing average parities that refer to the fertility experience during a specific period or between two censuses, rather than static lifetime experiences as in the standard method, and compare these observed intercensal parities with intercensal lifetime fertility equivalents. Given that there are observed average parities at 2 points in time, the average parities for the intercensal period can be estimated. If the interval between the two censuses is 10 or 5 years, then we can identify cohorts of women in the first census who survived to the second census and estimate change in the average parity of the cohort. See Annex 2 in this module for a detailed explanation of this estimation. Remember that you do not need to do any estimations by hand. The explanations provided in this module assist your understanding and interpretation of the results you will obtain from the Census PRM workbook. The method is divided in 3 stages. First, estimation of intercensal average parity for each census, for parity increments for intercensal cohorts, and for parities for synthetic cohorts. Second, estimation of lifetime fertility equivalents from average intercensal age-specific fertility rates. Third, once you have parity and fertility equivalence measures, calculate age-specific PF ratios and follow the same steps and considerations explained in Episode 2 for the standard PF ratios method for the estimation of the adjustment factor, K. The figures shown in the previous episode for age-specific average parities and age-specific lifetime fertility equivalents for the standard method displayed a gap that increases as ages increase. The PF ratios method for synthetic cohorts assume changing fertility, and as a result, age-specific measures for average parity and lifetime fertility equivalents are more similar. Therefore, the gap between these measures is smaller. Following from the previous figure, the resulting PF ratios for ages 20 to 34 are aligned, and in this case, closer to 1, indicating that there are no substantial underreporting of births in the 12 months previous to the census date. As in the case of the standard method, the method for synthetic cohorts requires a small amount of information which is often available from a standard fertility question in censuses. The method does not assume constant fertility. Let's compare both methods. The standard PF ratios method uses data from a single census and assumes constant fertility. The PF ratios method for synthetic cohort uses data from 2 consecutive censuses in different ways. When using age-specific fertility rates from the first census or survey, this method is not common. When using age-specific fertility rates from the second census or survey, this option is integrated in the Census PRM workbook. And when using average age-specific fertility rates from both censuses, this option is also integrated in the Census PRM workbook. Please answer true or false to the following 2 statements. First statement: the advantages of the PF ratios method for synthetic cohorts is that recent changes in fertility are incorporated in evaluations of coverage of births from censuses. Second statement: there is no advantage in estimating synthetic cohorts. It is just a more complex estimation. Here are the answers for the previous two questions. First statement: the advantage of the PF ratios method for synthetic cohorts is that recent changes in fertility are incorporated in evaluations of coverage of births from censuses. It is true. This is the advantage between the standard method and the synthetic cohort method. Second statement: there is no advantage in estimating synthetic cohorts. It is just a more complex estimation. It is false. Please select the correct answer. The underlying difference between the standard PF ratios method and the PF ratios method for synthetic cohorts is that A. The standard PF ratios method assumes constant fertility over time. B. The PF ratios method for synthetic cohort assumes a stationary population model. C. The PF ratios method for synthetic cohorts is based on model data. D. There are no differences. It depends on the user preferences. Please select true or false. The PF ratios method for synthetic cohorts requires data from one census. Here are the answers for the previous two questions. First, multiple choice question. The underlying difference between the standard PF ratios method and the PF ratios method for synthetic cohorts is that the standard PF ratios method assumes constant fertility over time. Second, true or false question. The PF ratios method for synthetic cohorts requires data from one census. It is false. The PF ratios method for synthetic cohorts requires data from two censuses.